right, we're gonna start off this class now. This is Josiah again on each one teach one. We are starting off hopefully the 19th day in our section for IT Foundation and AWS Cloud Training, codename iFACT. And I thank everyone for showing up today. We are going to continue from where we stopped, which means finishing up with CISSP domains, especially security and risk assessment and uh, domain 7 and 8. We will wrap it up. We'll certainly wrap it up today. So let's proceed and start doing that. I would like to share my screen with you. Not too many people in the class today, so regardless, we gotta make it work. All right. So let me share the screen, and then I'll take you to where I need to be. So we stopped here the last time in the green unit testing or component testing. Can you see my screen?
Yeah, I can see.
All right. So this is under security and assessment and testing, which is domain 6, right? Yeah. I'll I'll show you. Security assessment and testing. Okay, that's domain 6. So we've gone through this and we've gone through it all the way to here. So we'll continue. We'll do system testing. Last time we did unit testing and component testing. This is basically component testing. It's just a test you do to verify functionality of a specific section of a code. Okay, usually at the function level. So if you have 10 functions, you're testing the functions. You're pointing at each function where you want it to stop, and you test until it gets to that point and it stops, and you're doing it one at a time till you get it all done. So that's you are doing unit testing or component testing. Component is component of whatever class that you have. So there's also integration testing. Integration testing is individual units are combined with and tested with a group behavior. Like if you have a function that will do calculation, but you want that calculation that calculate, the output of that calculation to be entered somewhere else. So that means you have to group that unit or individual test with another sort of like unit, so that when you're done with this, the output goes in as an input to another thing, and it triggers a reaction, and the process will follow through till the end. So this kind of thing helps to expose faults. For instance, we are developing a mobile application, and in the mobile application, if we bring all the modules together and all the other little bitty pieces in it, I'm not talking about features, I'm talking about the core component of the application. And in order for the whole application to work, we have to make sure that the core components are working flawlessly. So you also have system testing. System testing will imply a system, right? Right? So system testing or end-to-end testing tests a completely integrated system or software to verify if it meets requirements. All right. So you test the whole thing to see if it meets requirements. So if I'm looking for a system that would check the temperature in my house and pressure, and check the maybe insulation in the house, and I'm testing it, it's not doing all of that, then something is wrong. So we do system testing to make sure that whatever the specification, whatever is in the specification, is what we're getting when we do the testing. So we also have misuse case testing. There are two broad categories. You have positive testing and negative testing. With your logical mind, what do you think is a positive testing? And then what if in that sense too, if one is positive, the negative should be self-explanatory. So what do you think should be a positive testing? Are you with me? Are you with me? Is anybody here? Aziat? I see Aziat here. But can anybody hear me?
I'm here. I can hear you.
Oh, okay. What do you guys think is a positive testing as opposed to negative one?
I'm not really sure. Is it in terms of the running the program, or
In
I'm
terms
sorry, I
of
just came
running
in late.
programs, yes. In terms of running programs.
Mm-hmm. That you're not getting the error messages that it would run through.
Yeah, that's positive. Yeah.
Mm-hmm.
And again, when you're checking it across, like say input validation, input data, how the application behave, is it behaving as expected? Because every program has to take some input, right? So if I'm asking you to give me a number and you give me an alphabet, what happens? Is it gonna behave as expected? Or
Yeah.
if error is encountered, it doesn't mean it doesn't work because error is encountered. So if you are catching an exception, when somebody put an alphabet, you should catch the exception saying you put in an alphabet, please put a number. You put a number and it works. Then in that case, if you put a number and it doesn't work, it's not positive test, right? Because it's not within the specification. You said, give me an integer and I give you an integer and it works. But then when I give you an alphabet, it doesn't work. It crashes. So that's not a positive test. That's a bad test, negative test. Okay. So the system, like the application behave as expected, and then when you put the wrong thing, an error is encountered. That means the test failed. But in a negative test, this is done to check system behavior if wrong or invalid input data is used. So in negative tests, the system is in negative tests, the system is verified against invalid input data. So you check what happens if you put wrong data, invalid data. Okay. So if I put wrong data, if in a negative test, if I put wrong data, it should do what?
Give you an error message.
Exactly. It should show an
It
error.
wouldn't run.
Exactly. But if it's a positive test, it should catch the error and tell you, please put the right integer. You put the right integer, the right data type, and it works. That's a positive test. But negative test, you are trying to test what happens when you put the wrong thing. See, one is positive, one is negative, right? Does it make sense?
Makes sense. Mm-hmm.
Yeah, because you're looking for all the good stuff in one, and the other stuff you're looking for all how the program behaves with the bad stuff, invalid type, data type, right? So there's also a misuse case scenario. You have a use case scenario, you have positive and negative test, and then you have misuse case test scenario. So in this case, the main purpose of negative or misuse case testing is to check the stability of the software application against the influence of a variety of incorrect validation data. Some misuse case testing scenarios are, so you have allowed a data limit and bounds. Like say you have an array, you already know the size of the array, right? And all of a sudden you want your array to contain 8 items, and all of a sudden you want to put 9 items. That's going to be a problem. So when you check the behavior of the application when that happens, so it's you have to check it for smaller than lower bounds or greater than upper bounds. So if you want exactly 8, then you have a problem when 7 goes in, and if you want exactly 8, you also have a problem when 9 goes in. There's also populating the required fields. This test checks the response of application when the required fields are not filled. Like have you gone to a website, you're trying to register, and they say this is optional, and then you see the other asterisks, red asterisks on some of the fields, and you try to submit. Remember what happens? It doesn't submit, it doesn't honor the form that you're submitting. It tells you to go back and correct it with the red indicating the red encirclement indicating that you need to correct something. So when you try to submit it without the required field, then it's not optional. It won't work. But the optional field, if you want to submit it with the optional field, then it will still work. So also have allowed number of characters. So some characters we require, like especially for password, password complexity will require more than 8, right? So if you put less than 8, then you have a problem. The password, the complexity will not work for you. Then there's also reasonable data. The test check the response of application when data entered into a particular field exceeds a reasonable limit. So for your SMS you need I think 140 characters. To be precise, I think it's 160, but they went down to 140. I think somebody could cross-check that. And when you try to send a message, and if it's beyond that limit, the message doesn't go. But nowadays with MMS, I believe they make it do it in different phases also, sort of like kind of just some stuff that they had in the past where if you want to send string that's more than 160 character, it's a problem for SMS. It's short messaging services, okay? So we also have web session testing. So this test checks the behavior of web browsers, which require a login when the user attempts to open the browser in the tested application without logging in. Exactly. Okay. So we have correspondence between that data and field types. The test checks this kind of test will check the behavior of the application when invalid data is entered into the specified field. So these are some of the misuse testing that we have. There's also test coverage analysis under this security assessment and testing. Test coverage involves a set of test cases written against requirements, specifications. Do any one of you remember black box testing?
No, what is black box? I've kind of heard of it, but not sure.
So in black box testing, what they are trying to imply is that you really don't know how the code or the program works, but you want to do a test on it. See? It is a type of black box testing where test coverage is a type of black box testing where it is not necessary to see the code to write the test cases. So you don't know how it even works, but you are writing a test case. So once a document is written describing all the test cases, the test groups may refer to percentages of test cases that were run, the passed or failed, and so on. These are referred to as test coverage metrics. So they are sampling. Okay, overall test coverage is often used by quality assurance groups to indicate test metrics and coverage according to the test plan. So test coverage analysis should be like okay, say I have a requirement specification like I want to build an application, and what I want that application to do is specific things. I want it to be like able to have a wallet where I can fund the wallet. However, whatever I use to fund the wallet cannot be exposed to anyone, and it will be on a local device, and it will be all encrypted. So all I know is what the specification says. I haven't checked the code or anything. So based on what the specification says, I am writing a test. You see, I am writing a test case. So a desired test case will be okay if uh, the critical information are exposed, or if that means the input that I have made an input and it recognized it as a credit card and then it encrypted it. What if it's not encrypted? The program is not working very well and it's not encrypting it. How do I know it's not encrypting it? Those kind of tests, I'll have to check those tests to see if the effect it will have if we're going to develop that program. So there's also interface testing. Interface testing is pretty much straight to the point. Interface testing checks if the different components of applications or system that is under development pass data and control correctly to one another. So I have to make a phone call in the app. So I want to make sure if I make a phone call in the app, it will call the right number, right? So these are interfaces doing that. I have an interface where I can key the phone number, and then I have another interface when I'm calling the person, it's ringing, it's telling me, uh, it's showing me some avatar that's ringing. You can see the sign that it's ringing. Either it's moving in and out, like in a very lighted manner, or it's something that tells me his phone is ringing. This is an interface. So we want to know if the flow is correct. So that's interface testing. You want to know the flow process is good and it's working according to plan. So for interface testing, you check if the APIs are not returning any value. If they are returning value, what kind of values are they returning? Are they the right response? Okay. If it's a website in the mobile app that you want to check, are you getting 02 okay, HTTP, coming back? Check if the API is triggering some other events, calling other APIs. If so, track and verify the event output. Check if the API is updating data structure. That means if it's editing files. So, does anyone know what API is? Does anyone know what API is?
No, but it says an application interface.
It should be application programming interface, yes. So
Yeah, application programming interface.
the application programming interface should be able to carry should be able to lay a pipeline whereby one application, which in this case a client, carries some information that is required, either for authentication or authorization, which gives you access to resource. This API is a pipeline that understands that lays down the pipeline with the understanding of the server where the resource is, and whatever the client is sending through with reference to what is already on the server to authenticate the person. So, for instance, one of the most popular uh, 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 methods for doing this would be JSON or SML. So you can define parameters like you can say name, what the name is, email, what the email address is, address, what the address is, as in home address, or other keys and values. You can show all of that. So these are taken as claims, which are now carried over following the way it could be a JWT, Java Web Token, or encryption as digital signature. Okay, so it could be either one of those, but it's pretty much JWT that is being used, especially in the web. So it carries that information over to the server who now understand what is being carried over. The process of understanding that and what makes it possible is API. Because with an API, you know how to communicate with me. You know how to send the right information to me. That way I understand you. So that's what API does. There's RESTful API, there's SOAP, there's other ones that are out there. So it's very important to understand what they're used for. So in API testing, an application programming interface or API specifies how one component should interact with another and consists of a set of protocols, routines, and tools for building software applications. API testing is performed for a system which has a collection of API. So for API testing of the system, the following are considered. So you are looking at verify the boundary conditions and ensure that the test harness various API call parameters in ways that verify functionality and expose failures. So verify calls with two or more parameters by generating more combinations of value-added parameters. And then verify API behavior due to external environment conditions such as files and peripheral devices. And verify the order of API calls and check if the API produces useful results from consecutive calls. So each time you make API calls, is it giving the right results? These are some of the tests that you do. So if you have an API that you want it to, every time somebody does registers, you want to carry the information, registration information to the other side. And when you are doing that, you're not saving it. It's not being saved in the database. That's a problem. That means the API is not doing well. Or you have some pin that you want to set each time. The first time the person registers, they set that pin. And then you have another API. Each time somebody logs into a system for them to use resources, you're asking them for the pin that they set during registration. So these are some of the stuff API will do for you. So there's also graphical user interface testing. In graphical user interface testing, it's used to identify presence of defects in product or software using the graphical user interface. So every software you see in graphical user interface form was started off from the CMD or command or string-like way. So the GUI is to help people to navigate around it and see it as a three-dimensional thing or as something that you can see and experience interactively, as opposed to the interaction that you get from CMD. That's different. So this kind of test, in this technique, the application's user interface is tested for performance. Graphical user interface is a hierarchical graphical front end to the application, which contains graphical objects with a set of properties. The security practitioner must be aware of the following characteristics of GUI testing. During execution, the values of the properties of each object define the GUI state. GUI testing has capability to exercise GUI events, such as key press. So if you have a graphical user interface, it says login, and I push login, I wasn't able to log in, test failed. Or if I have a graphical user interface where it says register, for instance, I went to Google and I want to go and register for a new email account, and I got there and I put all my information, I said submit, and it didn't work. It failed. And I go to log in, it didn't log in, it failed again. So these are the things that people in this business, designing business, they test these things to make sure that they are. Not only do they design it, they have the QA to test if they work. Okay, so there are many technologies that can be used for GUI. There are mobile technology for it's called mobile application. There are also web applications for the ones that you see on the website, etc., etc. So that's that for security assessment and testing. How hard was that?
A lot of information.
I know, but you have an idea. You're better off yesterday. I mean, you're better off today than yesterday.
Sure.
You know a lot more stuff than an average Joe. Now you can speak and say, hey, look, I know how this works now. Oh, with this mobile app, you need an API to communicate with the next other person because get them. call this. I want to make a phone call. I'm on WhatsApp. I want to call you. There has to be an API that does that, that carries that phone call and places the call to the right person. Okay, over the internet.
Mhm.
So we're gonna jump over to domain 7, which is security operation and investigation. So when you hear about SOC team, security operations team, we're gonna talk about the things that they do. Most of their job is investigations. They investigate and figure out what's going wrong so that they can fix, mitigate, remediate, and mitigate issues in the environment. Who can tell me the difference between remediate and mitigate? Anybody?
Now, mitigate, it says that to make it less severe, or let's see, what does it mean? It's to lessen the intensity, so I'm not really sure. So you
That's
said
right.
remediate?
Mitigate. Mitigate is like lessen intensity. Remediate means that something has already happened and you try to take care of, fix it. Remediation is okay, this happened now. I'll give you an example. A lot of people are not checking the EULA, except end user license agreement. They're not checking it off, and therefore the number of people that is using your website is not that. Nobody's using your website. Now you want to find out why is that. Maybe they don't see the little checkbox checkbox that you have on the side, so you have to remediate the issue by maybe building a bolder one with a brighter color so they can see it. But to mitigate is that um, the problem is a big problem, but you want to lessen it. Nothing has happened about that problem already, but it's there. But you want to fix it. You want to take care of it. So there's a difference between mitigate and remediate. You see, so with mitigate, you lessen the problem. Remediate in IT words is like, oh, okay, this problem is there already, so we're gonna remove it, make it stop happening. And mitigate is we're gonna lessen it. It's this big, but we want to reduce it to where it's manageable. So that's that. That's those two. So let's look at forensics. Forensics is the methodological way of handling investigations. So forensics, when we have forensics, what comes to mind is CSI, right? And all that, all those kind of crime movies, and etc. So in forensic, is just a methodical way of handling investigation of um, a specific interest, and there's an evidence collection which is also done methodically. There's uh, it could be a digital crime or any other crime, but in this case, we talk about digital crime. While a part of the incident response, forensic itself is a process that is used to preserve evidence. It is a part of the corpus when you have an incident in an organization. When you're writing report, lesson learned. If a crime has happened in that incident, you need to do your forensics. Means you have to collect specific information that will stand a chance in a court of law. You follow the process for it. So that's where forensic comes in. Also, if there's a case of child trafficking, juvenile cases where Justice Department is involved, you still have need forensic people to collect data, like from the hard drive, mobile devices, and any electronic device they can get data from it. DVD, all of that, CD, they can scrape data out of that, you know. So forensic itself, as you know, is a process. You use it to preserve evidence, and you use technique to maintain the integrity of the data and its environment. And at a high level, the steps of the forensic process include identifying the potential evidence, obtaining control of the evidence, analyzing the evidence for clues of the attack, and producing a report out of the evidence found. It's very methodical. You have to identify what has happened. After you identify what has happened, you have to try to once you identify, you have to try to see if an attack who might have been a part of the attack. You have to get the control of the evidence and then analyze the evidence for clues of the attack and who might have been a part of it. So the control of the evidence is very, very important. Identifying the evidence, controlling the evidence. Only by controlling the evidence you can be able to gain information or clues of the attack and who might have been a part of it. Now you produce a report out of the evidence that you gathered. That's forensic in a nutshell. Depending on the type of attack, additional focus can be paid to the media gathered using analysis tools against binary images of storage devices, network forensic, where the attack can be replayed. So have you guys heard of replay? So in replay, it's like replaying the attack, what happened. It's like a mirror of what happened, you replay it. So you have to replay it before it spread from emails to file transfer, for example. Say if it's a virus, right? It's a worm. It needs a media to propagate. So you have to do that. So additionally, software analysis can include reverse engineering, which is a part of forensics. Reverse engineering of malware to understand who possibly created the attack and to understand how it works. Finally, e-discovery, where electronic information, including data, emails, and documents, can be requested for use as potential evidence. It's an area where retention policies apply. So how long can we retain those information? On top of retention policies. For in the court cases, you need something they call chain of custody for those. So you also have data storage capabilities and data privacy. You introduce compliance challenge to the desk of security professionals. So all these things are like multi-tentacled. And I hope you guys can take it one day at a time, the exposure. So now after all being said and done, we have the incident response management, which is sort of like you have a pot, and the pot has many holes, and every now and then some of the holes are leaking. They leak, you have to patch it up, and the next one leaks, you patch that one up. Next one leaks. So that's what incident response is all about. So you are constantly patching up leaky holes. Okay, so people will send they will send alerts about possible breach or whatever that's happening. They don't know what to do. They have to run it across you as an analyst, incident response analyst, security analyst they call them, and then you have security operations center analysts, SOC people. You have the analyst, which is like you escalate. SOC will escalate problems to this security analyst based on the level, who now will determine what happened, all of that. But SOC are the ones first responder. They will get the information, they get the ticket of what's going on, and they do the best that they can. If nothing else works, they have to escalate that to the security analyst, who now will finalize the disposition. So a definite requirement, not only in the exam, for those of you that might want to do CISSP, there's a special publication 800-61RT for the process for incident response. And you have the preparation, you have detection, you have response, you have mitigation, you have reporting. Okay. So mitigation, you have reporting, you have recovery, you have remediation. Okay, lesson learned, providing a report. So this is like a kill chain, but it's not really a kill chain. This is for incident response. The steps that you take for incident response. You have to be prepared. you have to detect, you have to kind of find and analyze event to determine if a security incident has occurred. Okay? So for preparation, you talk about the training, must have had the training and education for it. You must have adhered to the policies for the company and procedures, where the policies is what and procedures are how those things are done. So you have to know the what and how before any incident. You have to also identify if there's a security incident. You have to know how to do that. You have to respond to it if there's one. Okay? When incident team works to contain and understand the attack. Okay? There's also a mitigation when a resolution or fix for a system attack is identified. Reporting is documentation of the findings, action taken throughout the event. And then you talk about recovery. Recovery is when, okay, now we have taken everything offline. We're going to make sure that we remove, we have taken everything offline and we have effectively removed, quarantine our system, and all is well, we recover. So this is the step we take to restore the affected system to operation status, right? Then remediation is making the system or administrative changes that were vulnerable. Okay, you have to make the changes for why something happened. You remediate the issue. So this is more administrative in a sense. So lesson learned: provide a report of the incident for improvement to be made. So if your company has a problem, what's the first thing you should do to solve the problem? It's right here. You can follow the process.
Well, yeah, you'd have training and policies in place before, right?
Exactly.
So then, yeah, then the following steps here: detection.
You follow
Now,
your
with
procedure.
mitigation,
Yeah.
mitigation, does it have anything to do with like patching, or like if you're finding areas that are problems and you're constantly mitigating, or is it like, are you doing that?
Detection is usually using monitoring tools to detect if something has occurred, security incident has occurred, like Splunk and etc. That's what they mean by detection. You have to find out if security incident has occurred. If somebody send me an email and it looks like it has a PayPal information on it, while in fact it's not PayPal, does that signify that incident has occurred? Security incident has occurred? Not necessarily so. So we have to determine that, okay, that security incident, once security incident has occurred, then we plan on how to respond to it. So that's that. So operational preventive and detective controls. So this is where your IDS and IPS come into play. So for preventive, you have tools like sort of like kind of firewall, okay, and what they do is to prevent attack from security incidents from happening, and you have intrusion, like what they call intrusion prevention system and intrusion detection system, and sometimes they are a mix of the two worlds, okay. So I don't know if any one of you have heard of a tool called Snort. It's like more or less an IDS, but they also have an IPS functionality on there. So the concept of continued and evolving preparation for security operations extends into the preventative and detective controls that an organization can have in place to monitor their systems. An intrusion detection system will be what? It has to be a device that's used to detect malicious events on a system, while an intrusion prevention will be one is a preventative device used to prevent malicious events from having the opportunity to occur. While the one detects something that's already in, one stops the thing from getting it in the first place. So each IDS and IPS system can be network-based or host-based. I remember using Commodore in the past. These are host-based intrusion detection system. There's also network-based, which means they will detect any malicious stuff in the network. And host-based means they will detect any malicious stuff on a node, like a workstation, a server, etc., or your laptop, stuff like that. So that's what that is. So when you hear network-based intrusion prevention device or host-based intrusion prevention device, that's that. So basically, when from the network, you are looking at where the device is placed. Can also affect how the network traffic is analyzed and even how it moves. With network-based intrusion prevention system, you have is authoring the flow of the traffic, because what it does is it will mirror or span the traffic is getting, meaning it will filter it, trickle down. Either it takes a copy of the whole traffic or it looks for certain things based on signature or behavior and anomalous behavior, they call it. Okay, you look at it. Signature means it has a hash of every possible attacks or whatever, hash of every malicious software that's out there. But heuristic is based on the behavior. If something is not the same what it used to be in the network, it will now figure it out. Actually, no, behavioral means if it is out of the ordinary of the network behavior, that particular network behavior, then it will figure it out. So there's one that's based signature based, and there's um, also a behavior. These are some of the major technology that they use to design them, the rules on them. So when something goes wrong, you get an alert. But for host-based system, they only focus on traffic as it enters a host. That means it's already in the host. Okay, so you have a process, dataset, systems, or an application. They use patterns, behavior analysis, and anomaly detection. Okay, I was right on that one. And anomaly detection. For anomaly detection, it has to be something out of what is normal for that particular host. Then behavior analysis is it has to be like all the known way of the application how it behaves, but this one doesn't behave. It doesn't match those kind of application. Maybe this is it's saying that it's HTTPS, but it has something else in there. Maybe it has something encrypted in there and it's coming through HTTPS, stuff like that. The behavior is different. Instead of the encrypted stuff to go through port 443, it's going through port 80 and stuff like that. Okay, so there's also pattern. Okay, you can liken that to like taking a hash of everything already and it checks it to what is already out there. Okay, so security information and event management tools are also used to ease the analysis of data coming in. Like I said, Splunk is very vital. So some of the tools that's used before Splunk, there's a tool called ArcSight that was out there. It was being used to do the same thing. All right. So these tools are used to analyze this data coming out of various systems as a way of identifying trends and monitor operational risk in a more automated fashion. When used with other tools like data loss prevention, endpoint security, tools like antivirus, whitelisting, encryption, and media controls, security professionals can constantly monitor the threats to their assets. So let's take a look at configuration management. So configuration management is an interesting part of this. Configuration management is a discipline for evaluating, coordinating, approving, or disapproving, and implementing the changes to artifacts used to construct and maintain software systems. I think I want to take some questions here. There seems to be a lot of information, and I don't like the lull between me and you guys, so I want to hear something from you guys, see what you guys think.
Like I said, it's a lot of information, but it's just thinking in terms of, like you said, as far as issues that come up, preparing for it, and some of the different tools that you can use. It seems like, you know, just being aware of it or the training. Because some of it I've heard, but then it's like a lot of it sounds really new when it comes to the business side, or just like as far as the mitigation. I had heard that before, but like it's a lot more to it.
You've had the mitigation part to it. Okay. All right. You've been in the field for a while. Yeah, you've heard that for sure.
Yeah.
So let's.
The only thing is I'm not actually doing. Go ahead.
You're not actually doing security at this time, but sometimes in the future, you never know
No.
what could happen. They could like be like, "Oh, we need somebody to do this for us. Can you do it?" You say, "Oh yeah, I
Right.
can do it. I have a little idea of such and such," and then you tell them what you know. They'll be like, "Oh yeah, you can do it. You just take your formal training and get trained up for it. No problem. Take the position." Because organization wants to hire people inside when it comes to security before they consider people outside. Because that's one of the things that we are taught in security. Insiders are much better than a new person that's outside that we don't know very well. Like if I've worked with you for 5, 10 years and there's a security position and I want you to have it, it's much better for me than to hire an expert that I don't have a record of what they are doing. You know what they say, the more
That
they
makes
know, the more high risk they become.
right. Now, are they more willing then to get that when you're on the inside? Are they more willing to help you get that training or to go for that certification?
Oh yeah, they pay for it.
Mm-hmm.
But you have to show initiative by doing stuff in that area, showing initiative, engaging. They can tell. They can have an interview with you. They can tell. They'll be like, you know what? This could be a very good talent for us in this plantation. Let's get this one trained up in this plantation. That's how they do it. Yeah. If they think you are resourceful, they train you. They pay for it. They don't care because they know they're gonna get the money back. Within 2 years, they get the money back. So let's look at the client-based vulnerability. Let's use our logical mind to actually look at what could be a client-side vulnerabilities. Come on, guys. Come on, guys. This should be easy.
It says inadequate authentication. That's what I'm saying here on the server end.
No, this
You
is
have like
client-side vulnerability.
Firefox.
This is client-side vulnerability we're talking about.
Mm-hmm.
Exactly, authentication. But which when you say authentication, are you talking about inadequate authentication, like you just using password to get access instead of engaging multi-factor authentication? Is that what? Can you explain it to us so we can understand clearly?
Well, I'm thinking that, yeah, inadequate in terms of authenticating, logging in, like you're using the same password or a weak password, or you're not changing your password, or you're not using an additional way to
Advanced authentication. Yeah.
right.
Yeah, so that's what it means. So if you are using just one thing to authenticate users, you might want to consider using a multi-factor authentication, which includes a physical device, primary authentication device, or maybe a software authentication device where you get a code and you put the code back in the client form, and then you go back to access stuff. So that's what they are saying here. So server-based vulnerabilities Can you guys mention some? That's a bunch of them. Come on now. Have anybody heard about OWASP top 10 vulnerabilities?
No, I haven't.
Okay. All of that you see there could be on both sides. It could be on client side. It could be on server side. So whenever you're doing anything in the field, always remember OWASP top 10, SQL injection, broken authentication, vulnerabilities, cross-site scripting, where somebody is gonna fool you and perform a. I mean, not that one. Cross-site scripting, yeah, where somebody's gonna fool you and perform something by making you think you are on this website. Maybe you are on a website like say Facebook, and you go and click on a link, and that link takes you to somewhere else that looks like Facebook again. And in that process, you enter your username and password again. By doing that, what did you just do? Somebody was able to fool you and take you somewhere else where you put information that's vital, and they're gonna use that information that's vital to access the system on your behalf. So that's what it's called
Is that like
cross-site.
phishing in a sense, or is that?
Yeah, because
If you're are they like fishing for information?
if you're using the same username and password for the same thing on a Google website or whatever, I can send you a link in a group, a forum where you go to. I send it there. You saw the link. You think the link is one thing while it's another. You click on it. It takes you to the place that you normally go, and you put all your information. And I grab them, especially your cookies. I can get your cookies like that, and then I use your cookies to access other places that you have used the same username and password. But this time it has to be the same domain or whatever. Like you know how uh, you have you have, like, for instance, you have a Facebook account, right? And you have another Facebook account again, and you're using the same password. So I can get that from you now. So there's also the sensitive
So the
data
main
is,
thing with that,
huh?
I was going to say, so the main thing with that, I mean, sometimes you are not. It looks like a similar, a link or something that looks familiar. Like sometimes, they could have like a logo on there that you may have be familiar with, and you click on it. So you're saying they can get your information from that. Is that now? How do you prevent that from having like some type of protection? How would you, other than just not clicking on the link?
Just not clicking on the link and report it to the security team, and they'll take it from there.
Okay.
So in some of attacks, there's many things happening in one attack. Phishing happened here. They sent you a URL. They could have sent you an email to click the same URL. That's phishing. Okay, it's just spear phishing straight out. That's what you see there, and that happened. And there's also cross-site request forgery or certificate request forgery. Cross-site request certificate request forgery. Yeah, CISSP. So this is where they steal your authentication tokens. Yeah, cookies that carry the authentication tokens. When you access the other website, they can use the information from there to access and get your token, and use that token to forge certificate based on the information that they learned from that one. There's also SQL injection, which is very simple. SQL injection is like say if you come to a website, let's find a stupid website. A website like let's say a simple website like this, and say we click on it, and we go here, and we put something like this one, or I'll put something like this. Okay, so this one is not susceptible to SQL injection. So you put some funny characters and you see the response you get. Let me go back again. Put funny characters and see what you get. Like you put something like this. So there are a bunch of characters like commands that you can put, and it will give you response. All this response it will give you will show you that you are interacting with the SQL database, right? So if you look at SQL injection responses, SQL injection. Okay, so there's blind SQL. There's a couple of them, but I was just trying to see if I can get. Okay, I've seen one thing that we can do. Okay, let me accept this. So we'll scroll down a little bit. See this? See this? See? All of that. All of that. That's how you play with it. First of all, you need to find out what the website is built for. There's something called, I think it's work built. It will be able to show you what the website is built with. Not sure if it's this one. So there are so much tools online. So it will show you what this website is built with. If it's built with PHP, then you can try those commands that we just saw here, and it will now start guiding you to give you stuff on the database. Once you get to this, you start playing and you start sending query, because you say ID2 and it comes back with a response for ID2, which means, oh shoot, this SQL is a SQL database, and you start writing queries directly and get what you want. So you should take note that everything is vulnerable. You just have to learn how to get into it. That's all. Alrighty. So moving forward, you have malware. Malware is a little tough. They are more advanced. They are bigger than worms. So these are some of the stuff servers suffer from. So you have large-scale parallel computing vulnerabilities. So you have parallel computing has advantages that are pretty apparent to any person who knows their way around programming. While it is good to let different computation take place, but it has its own problems. If not properly handled, parallel computing can also leave your system vulnerable to various kinds of exploitations. Some of the most famous vulnerabilities can lead to one, unauthenticated access granted to a masquerade. Masquerade is a rogue person or nefarious actor. So you have deadlocks in process, you lock yourself out, overriding of pertinent data because of race conditions. So these are some of the problems in parallel computing. Is pretty fast and powerful, but it has its own downside. There's also distributed systems, vulnerabilities. You have passive tab, you have active tab, you have faking attacks, play attacks, traffic analysis attack, accidental access attack, denial of service attack. Does anybody know denial of service attack? Somebody else should know that. Is Charity here? Is Janelle here? She should know that.
I'm here. Yeah, I was just thinking, is that when they flood your with, oh gosh, I know, I can't think of it.
That's when
yeah, I know when they flooded it. Yeah,
the network with corrupt, bad request. So it's too many responses to make, but it's not fast enough to accommodate all that request. So you get drowned by the responses that you have to make to the request. So it's like I can do 10 responses in 1 second, and you are giving me 1,000 requests in 1 second, while in fact I can only respond to 10 in 1 second. And here you go, you are giving me 1,000 requests in 1 second. How can I make it work? The whole system is gonna be clogged up. So that's what is called denial of service. Distributed denial of service when the bot is doing it, when the bot is the one that's sending those requests, right? It's masquerading. It's a bot. It's not a human person. So that's what it was. So this happens to be one of my favorite area, cryptographic system vulnerabilities. So in here, it's straight to the point. Cryptography is just a study, and it's a body of the science cryptology where you study the science studies how to hide something from people who are not authorized to have those information. That's what the science is all about. Okay, so with cryptography, the methodology can go a long way in ensuring the online security of a system, but only if their security aspects are also addressed. Among the vulnerabilities that we have discussed so far, we can safely say that once arising due to a faulty or obsolete cryptographic implementation can lead to easiest pass into a system for a hacker. For example, if you are using a Wi-Fi at home and you are using WEP instead of WPA, you are out of it. Actually, you should be using WPA2 enterprise version or personal. If it's personal, it has to be TKIP. But if you are using WEP, you're wasting your time because somebody can crack it using a crack NG. So that's what they meant by cryptography. If you're using an obsolete one, refrain from it. But we have a problem today in the world. The cryptographic system we're using today is failing us. You can Google it and check that information online. It will tell you that we have a serious problem. In a year or so, quantum computers will crack everything that we have out here, whether it's a bank and so on and so forth. So that's the problem. That's one of the problems Lockdown is solving because we devised a new system of encryption, which is very high that can resist quantum cryptography. Today we have AES, which is only 256, but the system we developed is about 10 times bigger than that in capacity, and it will stand quantum computing. So some of the problem with the algorithm to do a cryptographic algorithm, you have to be really out there. You need to know what you're doing. Okay, you need to understand how it works. So coming up with a new way for people to encrypt their information. It's not that easy. Okay, so there are some issues currently. Like I said, in public key infrastructure, there's a problem with the key management, keeping the private and public key, revoking them when private key is lost, using extended validators for certificate authority, and etc. etc. There's a lot of issues with that. Okay, since now we know that iOS and math is already been solved, computers are solving mathematics faster than anybody else could because computers are very good with logic. So you can beat computers in logic. It's already proven. Computers beat the deep sea beat the best chess player. Everybody knows that. What's his name? Kasparov. The machine is beat that a long time ago. Okay, another problem we have is pseudo-random number generators. The cryptography we use today, almost all of them are using these keys that are generated PNRNG, PRNG keys, which are saved. And we don't think that's the best way to do it. You shouldn't save that at all. The way we are going in the world of computing. So it's some of the problem we are solving. Now, this is the interesting part. Business continuity management. This is a sweet part. Everybody here should know about business continuity management. That's an approach that most companies have, so that in the event that something happens, if there's a natural disaster or whatever, that the business can also operate. Okay. And this goes hand in glove with what they call disaster recovery. So in the event that something happened in an organization, you can have a way to recover from that disaster. And it's a part of business continuity. And some of the policy documents that supports this procedure is what they call um, COOP. Can somebody Google that document? COOP is a contingency planning document. So most companies have contingency planning, which is pretty much the same thing as business continuity plan, which is a part of the business continuity management. Okay, so business continuity management is a systemized approach to ensuring the critical business functions can be managed or recovered in a timely fashion. So following our international standard 22301, a business continuity management system emphasizes the importance of the following: understanding continuity and preparedness, as well as the necessity for establishing business continuity management policy and objectives. So under the policies, you have the business continuity plan, and then you have implementing and operating controls and measures for managing an organization's overall continuity risk. And then you have monitoring and review the performance and effectiveness of the business continuity management system. And you also have continual improvement based on objective measurements. So the only thing that's missing here is disaster recovery. You can read that up. It's in line with this. Disaster recovery, the name is very clear as explained. Disaster has already happened, and it's the same thing as business continuity in the sense of the policies that need to be used for that. So, finally, on domain 8, we're talking about software development security. So, software lifecycle concept, you have that. Security controls, security in software environment, database security, security issues related to personnel management, and risk management. So, software development security, in software development security, it deals with developing software, right? So, to develop a good software, let's use our logical mind. What do you think we should do before we start developing any software?
You need to know what you're using it for, what it's intended for, like what's the purpose?
That's right. It's called threat modeling. You have to do threat modeling on it. What are we building? Why are we building it for? Who is going to use it? What are the dangers if we didn't build it the right way? What are the entry points and trust levels, etc., and etc. You have to use threat modeling models like the one developed by Microsoft, that's Stride, that's Dread. You have to put that into consideration. Security has to be built in any software you develop. You don't build a software and after you put security in it. No way. It's a recipe for disaster. It has to be a part of it, part and participle of it. So in software development life cycle, we also have the system development controls. And system development is a series of steps for creating, modifying, or maintaining an organization's information system, right? Mm-hmm. It can be used in various ways, used in developing, modifying existing information system, used as development processes and maintenance of information system. It's also known as system development lifecycle or software development lifecycle. But now they have secure software development lifecycle. Okay, they have that now. So you see below software development security checklist and list the controls in order of priority. So you have number 1, verify for security early and often. You see, I said that security have to be in it from the onset. Parameterize queries. Okay, so you cannot put queries like anyhow, like in the body or stuff like that. You have to parameterize them. There has to be a key and a value to the key, and etc. and etc. you have to encode data, like you put them in base 64, which Miami uses for email, and it's widely used in HTTP and HTTPS when they're passing through the internet. And 4, validate all inputs, implement identity and authentication controls. You must have your entities supply you attributes. With that attributes, you build their identities if the identities are not already built. You get it? You have to implement appropriate access controls. Who does what? If you register into my system, what can you do? If you're not registered into my system, maybe you can read this document, but you can't do anything else. Stuff like that. You also have to have a way to protect data so that CIA will be in place, confidentiality, integrity, and availability. Therefore, the wrong people cannot read the right information. You have to implement login and intrusion detection. So if somebody intrudes the system, you should be able to find out. So you implement login. So you take records, you log data. Like for instance, if you come to your website that is supposed to be protected, and you want to download something, and we don't know who you are, it's a problem. So we have to get some information from you. Whether you log in with using your Google profile or Facebook profile, then we extract some information from that, which we log it down. So in the case in the future something happens, we can say this IP address, this email address from Facebook logged in here. See? So we can also leverage security frameworks and libraries. Error and exception handling should be a part of your coding. You have to have a way to respond to wrong input. And you have to also respect security frameworks like NIST and standards and OWASP Top 10. These are well-known frameworks out there. So software development lifecycle models, there are various models. There's waterfall. You take your time. It works on the principle of finishing one phase and then moving to the next phase. So it's waterfall. Then you have a V-shaped model. This one is like Wi-Fi. This model known as verification and validation model. It is similar to waterfall model, but with each phase there is a corresponding testing phase as well. So you have the iterative model. This model is based on repetition. Do the same thing over and over. Keep testing and doing all of that. So there's also a spiral model, a very flexible model for SDLC. It works on the principle of iterative model by repeating 4 phases again and again in spiral, allowing for what improvement with each round. This model can result in a customized product. So there's also a big bang model. It doesn't work in a specific process. It's only suitable for small projects. It's just there's no specific way. But the most famous one is Agile, which also has Scrum under it. The Agile model relies on customer interaction and feedback. It breaks from inception. You go through analysis, design, and implementation. Each step you're going through, you're analyzing it and doing that. When you finish, you go back again. That's the Agile for you. The product is tested with each iteration. Each stage is tested. You test. If you do inception, you go to uh, from inception. That's the ideation state. You have the idea, then you plan it, then you analyze it. You go back again to plan, and then you go back again to analyze it. You go back to implementation, go down to implementation, you go back again to analyze it. That's how Agile works. So I think with this, we have done well. We wrap this up real quick. We've done amazingly well, and um, we have about a few minutes left. So with that few minutes left, I'm gonna help you guys with setting up a VPC. This time VPC with public and private subnet. I will go back and visit the subnet again and see how it applies here. You guys now get an idea of everything. So I need you guys now to ask me a question, and we'll move right away to setting up the VPC. And like I said, I posted it that we're gonna do that today. And I sent the tutorial here, which is right here. I sent it. I actually asked you guys to do it before class. Did anybody do it? If at all anybody did it, how did it go? And what about the code that we had a problem with? And I asked everybody to download Python 3.7.2. Did anybody test it out? Please, guys, these are serious.
Did the VPC?
No, I already heard from you. You said it didn't work.
No, I
Oh,
said I did
oh,
the VPC.
oh! You did the VPC?
Yeah,
Awesome. You want to show us? Oh,
I deleted it, but I've done all the screenshots. It's in
oh,
my folder.
oh! You sent out a screenshot. All right, fine. So let's go ahead and do it. I'll walk you guys through to it. I prefer to make a video for it, but with that being said, let me go ahead and see what I have here. You guys can see my screen, right? Right?
Yes.
Yeah.
So I have a bunch of elastic IPs that I'm not even using. I see you created an elastic IP. You didn't delete that, did you?
Who, me?
I'm asking, did you?
I deleted all of it still. All of what I did, I should have deleted still.
Oh, what about your elastic IP? Did you delete that? No?
I believe so, yes.
All right, cool, 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 cool. So let's go back to our group and let's go and create. Let's go and create this. We create the VPC. I'm glad you did the VPC part. That's awesome. Like that. All right. So I'm gonna log in here. Um, I'm gonna log in here real quick. I'm not gonna log in with my IAM user because I don't know the password to that. Forgive me on that. So let me just go. I know the password to this one. So I'm gonna run quickly here, and we're gonna log in, and we're gonna do the VPC real quick. So Natalie did it. Natalie can direct us as we are doing it. You are officially allowed to do that. She did it. Very, very good. So I'm going to my update so I can get the authentication code that I need to get in here. Okay, so just give me a few minutes. 753. All right, hopefully we're in. So we should be in. So now that we're in, I went and I created a VPC. As you can see, I was right on it. I was about to get the gateway going, and okay, I was about to get the gateway going, but I will just go back to everything and show you guys what I've done already. Okay, so we're at the dashboard now. So this is the VPC that I have created, but I didn't finish it, as at least I didn't get the gateway done. So what I did was I went and I created a VPC, which is this available, uh, which is this one. I can actually delete it. I can delete it. Then we can create another one. Okay. That way it will not be complicated for us. Oh, I wonder why. Okay, let's go to this one. One
Click the
second,
bottom
one
link
second.
first.
Let's go to this one and get rid of this one
No,
first.
just the bottom. Okay.
We'll get rid of this gateway first. Yeah, I don't know who owns this gateway. I'm not sure I did any gateway. Might be someone else. Okay, let's do it. Delete confirmation. Delete. So we deleted that. That's gone. All right. Now let's go back and try to do the same thing to the other one, guys. So can somebody tell me what a VPC is? Amazon VPC. While we're doing this,
I was going to ask you. As I was looking it up.
it's the same thing.
Virtual private cloud.
Right.
Exactly. So why do we need to create them? Why do we need to create them? What do they do for us?
Is it so that we can have our own system going on? So like there's like basically you can like how you can upload your like whole setup onto like say the AWS cloud for instance. You can create like a separate private cloud inside for your internal workings.
Absolutely.
Okay.
So now when we delete this VPC, these are all we're gonna delete. We're gonna delete the subnet, security groups, network access control list, internet gateway, egress online gateway, route tables, and all of that. We're gonna wipe that all out. Wipe it out. All right, it's gone. We no longer have the VPCs. We can go out here and check it. Like right here on the history, we click on VPC, we come back. We no longer have that particular VPC. We only have this VPC, and this VPC is public subnet, as you can see by the IP address that it has. So if it wasn't a public subnet, if it's a private, you will see the private IP address. Okay, so it's sharing this IPv6 side with silent notation. What it's telling us is 172. This is not to prove that. I can also go here and show you over here. Okay, 172. You see it? All right. Okay, so that's done. So now we want to create a VPC with private and public subnet. So how do we do that? We go here, over here. We can launch the VPC wizard. Okay. We have to do this, the VPC virtual private cloud first before we put EC2 in them. The reason why you create virtual private cloud, you want to make your own separate from every other one out there. So you can have your feature securities only and make sure that nobody else can come in there and cause problem. Your favorite lizard can come in there and start crawling over things. We don't want that. So we create the VPC, which is AWS cloud. Inside AWS cloud, you have the virtual private cloud. Inside the virtual private cloud, you can have your gateway that connects the internet to your public. I mean to your public, and your public connected to your private, so that your private, which is internet, can go to the internet using your public. So to connect the outside world to the inside, you need a gateway. So to start off, let's launch the VPC wizard, which is we're gonna do. The one where every one of you created is this. What you see here is what every one of you created. That is why we set up the security group, so that we make sure that not everybody goes through and interact with what we're doing. Oh, it's my son. Just give me a second. Hello? 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 Oh, just give me a second. I think my wanted to say hi to daddy. Oh, I hope you guys don't kill me here. I'm just gonna tell him I'll call him back. All right. So this is what every one of us has. Did you guys check? Can you guys see my screen?
Yeah.
Yeah, I
So
can see
that's what we
it.
have. But I decided that we need to expand our knowledge by creating VPC with public and private subnets. So now this is what you have on a high level, the architecture of it. From here, you can see that the internet is here. That's where your S3 and everything is at. And then you have your Amazon private virtual private cloud right here. And inside that, you have your public subnet. With network address translation, your public subnet interact with the private subnet, which is internal. The same thing that happens in your house. You have your modem and you have all your little computers inside your network. But outside the world, I see you as one big old IP, which is your public IP. That's how I see you. But when I go through that public IP and I come inside your network, all of y'all have 10 dot whatever or 192.168, etc., which are private. All these are all private IPs. So that's the same idea here, only that this is the cloud. Okay. So what we do now from this, you can understand that your S3 could be somewhere else. However, we call it cloud. DynamoDB could be somewhere else. We call it cloud, etc., etc. So now we're going to go ahead and look at this and read it, what it says. It says create, this will be able to create a /16 network with two /20/24 subnet. With that being said, we know /16, we're going to have a whole lot of computer set up, 2 raised to the power 16. That's thousands of computers. And then we know 2 raised to the power 8, that's 256 computers, because /24 will have another octet left, right? Because all of the IP addressing have 4 octets, and /24 is how many? 3 filled, 3 octets filled. So that means the other ones are empty. 0000 up to 8 of them. 2 raised to the power 8 is 256. That's what you have in that subnet. That tells us that, based on how I taught you guys that before, you have 256 for each of the network. I mean, for the network right there. Okay. But based on the number of, if you have, say, how do I explain it again? For instance, you have 150 computers and you're doing /24, it's gonna work. Because why? The /24, you should have 256 there. Okay? You should have 256 there. Then for /16, you have 2 raised to the power 16. That's a lot. Okay, so it's telling us this is able to do that much many. And then we're gonna go and we select. There are a few things we have to understand here. So for this, I think I want to do /10 here. So it will be truly 16. All right. And then I will leave it as it is. And I'll put the name, not within the range of, okay. Oh, don't worry about that. We'll fix that. So here, let's choose a name for it. Let's say it's VPC, private, and pub, like that. And here, we'll also have to change this, like that. Okay. See what I told you guys? 251 IP address is available. This one is 65,000 available. See, public and private. So the public one up to 255 available. The private one, you can set up to 65,000 computers in Amazon cloud, and nobody knows. And it will share these IPs here. So in this case, I like to use what they call elastic IP. In this case, however, let's proceed for the gateway. Use elastic IP for the gateway. So let's proceed. So we have 2A as an availability zone, West 2A. So we can choose B for availability zones. Oregon is West 2A. Yeah? So we can private subnet IP address, and we have to change this again and click on there. It takes care of that. So you have public here, 251. You have private this. So you have this, you have that. Now specify the details of your NAT gateway. NAT gateway rates apply. Wow. Okay. Let's go here. First of all, let's go back. Okay, let's choose this one since it's the only one that we have. Okay, guys, this is the elastic IP that we have, guys. So let's choose this elastic IP that we have. If it's not open, then it will tell us, but I think it is because I've done it before. So now we have to do the gateway. The rate applies. So what the gateway is how the virtual private network connects with the outside. Like, okay, let me see how I can show it to you guys. Okay, you have paint. Can you guys hear me? Can you guys hear me?
Yeah.
Okay, this is what the gateway does. It's like the gateway you have in your house. You can't do anything if you don't have that modem or that modem router that you have in your house. You can't communicate with outside. It's the same thing here. So you have AWS here, VPC. Inside AWS VPC, you have your maybe your EC2 is. I mean, you have your one subnet which is public. You have another one which is private here. Okay, okay. Now there's a pipeline between this and this. There's a pipeline. Can somebody tell me that what that pipeline is? Somebody smart is here. There's something that makes it possible for people inside the network to communicate with outside. What is that? It is in your house. You have it in your house.
It's your modem, right?
It's your modem, but there's a technology it's using. Your modem is using a particular technology to do that. Have you ever heard of anything like network address translation before?
Yeah.
Okay, that's what it's using. That's what it's using. So you have AWS Virtual Private Cloud, and then you have your subnets. You have your subnets here. Inside the subnets, you have the public and private. See, you have the public and private. But something is very interesting here. How in the world will the outside world communicate with these guys in here? That is why you need a gateway. See, you need a gateway here. GW. That's how they communicate. How are we going to access it if there's no gateway to lead us to where we need to go? So you need that there. So if I'm using party to get in here, so the gateway does that. If I'm using party to get into to here, the gateway will have to take care of that. See, the gateway does that, and I use it to communicate, to go through here, the pipeline. I use it to go through, and I communicate with everything that's here. That's how it works. It's not complicated. So you have the private, which is the holy of holies, which is like your house, inside the house here. You have the public, that's internet facing here, not completely internet facing. You know what I mean? It's the first place an attacker will hit. This is public. This is this is the public subnet. Okay. So here you have AWS VPC, and here you have subnet. You have the AWS subnet. right? You guys can see this, right?
Yeah.
Yeah. Yeah.
So you have your gateway here. That's through the gateway you come in here. So when you do your SSH or whatever, you need this gateway. Without this gateway, you wasted your time. So that's that. I've shown you that. So now what we do now, we have already connected the Elastic IP to this, and this is a different availability zone. Am I correct? It's a different availability zone. Let's check. Yeah, it is 2B. All right. So there's something that's left. We have to get the gateway. There's a pricing involved here. Uh, there's pricing involved. Seems like I have to sign in again. Okay, let's do that. So gateway. Gateway. Hmm. Doesn't look like what I saw before. Let me go back. Mm, this has nothing to do with what we are doing. Wonder why it's there. So we are at this point now. Specify the details of your use a NAT instance instead. Use a NAT instance. Let me click on this and see what I get, guys. Oh, instance type 2 nano. That's the cheapest one. Okay. The keeper. All right. I'm gonna use this keeper, guys. I have it already. It's been used here before. So I'm gonna try to use it again, okay guys? So now let's go ahead and create the VPC. It looks like everything looks fine. I enable DNS host so that when I use the DNS to get into it, it will allow me through party. So let's create it and see what we get. So Natalie, when you did it, is that how you did it?
Yeah, I used the gateway instead and put in my key pair.
Oh, you put your key pair by yourself?
Yeah, I did it the same way you just did it with the gateway.
Oh, okay, that's awesome. So this is the one we just made. We made this one. And I will elaborate on that one and show you the difference between the two, okay? So for this one, let's check the subnets for this one. You see, so you see the subnet, you have the public subnet, and you also have the private subnet. 250, 251. Remember, in the public subnet, I use the NAT. NAT has taken one IP from us, as you can see. Okay, the other subnets that I already have is ABC and D, and this one is also here. And we can go all the way and check the availability zone. The availability zone for my public subnet is this one. Apparently, I did not change the availability zone for the private, but it's good though. That one is in D, another is in D, so it will be a good exercise for us. Okay, so with that being said, let's go back to the dashboard. Let's go back to the. Natalie, did you try to access yours once you were done?
I just checked that it was there and then screenshotted it and then deleted it straight after.
Oh, you didn't try to access it?
No.
So let's look at the network. Oh, what's going on here? Oh. Oh, it's not done yet. It's not done. It's not finished. Yeah, yeah, it's not done yet. It's still doing something. Because I'll try to go back again to that. Subnet gateway, internet gateway. This one is new. Internet gateway is new. Wow, that's amazing. We have to do something with the routing table. Okay, this one is explicit subnet section. Yes, yes. Let's see. Action. It seems like I have to create a routing table for this. Let me see. Because I have to know where to send stuff to. Did you create the routing table for us? Yes, I'm sure you did it.
Excuse me just a minute.
Yeah, go ahead.
In relation to the routing table, what is the I mean, what is the relationship between the public and private subnet in relation to the routing table?
It's pretty much where you're gonna send it. Like for the public, it's gonna there has to be a gateway because the network address translation is being done through a gateway, right? Because the gateway is
Yes.
saying, "Hey, this is me. This is IP for every device that's behind my router or my whatever." That's what it's saying. So we need to have a way to send stuff to it. I'm not gonna make any routing table, to be honest. What I'm gonna do, I'm gonna try to access what I've already created. I don't want to confuse anybody because when I was reading this tutorial, I didn't really see anything about routing table, to be honest. I'm sure that's why Natalie didn't do it. So we ran the VPC. We did all this stuff that they said to do. It says the wizard created VPC with single and all that network. And then we did the side up block and we did all of that. I specified and make sure that I gave it the right IP. Instead of 10.0, I used the /16, did it appropriately, got 256 nodes for public and private. I took care of that. If you have created your VPC, you should consider the following next step: working with security groups. Okay, and all of that. Okay, let's just go and see if we can access what we created and see if it runs. And next time we can do other stuff with it. Okay, this is where we are. So let's go to services and go to here. Let's go and have an EC2 stand up and at least put it inside there. Yeah, that's what we're gonna do. Instance. Let me check it again, see if it's giving me that same error. Do you guys remember what this is? Always try to name your stuff so you know what they are. This is the gateway, NAT gateway. I like to name it so I know where it is so I don't delete them. I delete what I know. So this is the T nano that we used to create that. Okay, that's taken care of. We go now to this. And now we have to, everything looks good. So let's see if we can stand up an EC2 here in that US West 2B. All right, guys? And then we try to access it. And while we're creating it, we make sure we have a security group set up and we use PuTTY to access it. All right, so let's do this. Looks good. I just want to launch an instance. I go down here. I'll launch an instance. Install an instance. Okay. So we look for something. We look for anything. So let's go for this one. Okay. We go for this one. Free tier, as you can see, you can get it for free. And then let's go through it step by step to see, make sure that it goes where we need it to be. We go to the next. We go number of instance one, network. Don't you think we want this one? That's what we wanted. And we want it in we want it here. Next time we create one for private, let's see if we can access the two. Okay. Now, auto assign IP enable. Then capacity reservation, we leave that open. And then we go to IAM role, S3 admin access. So if you belong to that group, you should access this. All right. So shutdown behavior, stop. Okay. I think everything has look all right. Let's just get this thing done. Add a device, enable metadata, storage. The storage, next is storage. Whatever they give us, we take it. We're just trying to make this work. And next is the tag. We just say this is the public one. We just say this is the key is public, and the value. No, we say subnet one, subnet 2. The key is subnet. Then we say this one is public. Okay, so we do it like that. And then we go to security groups. Well, let's just say, let's just use existing one. Okay. Hopefully it works. So here, all traffic. Let's just do that for now. We'll deal with it later. So the security group is here. Storage is taken care of, and then we launch it. So choose an existing key pair. We have this one already in this system, 2020. I'm gonna use that. And let's get it done. It's all done. We did it. Let's go back and review the instance. Okay. So this is the instance. It's not completely done. I think it's this one.
Okay.
What did we call it? We call it VPC pub. I think it said pub private or something like that. Pub private, I remember. Actually, that one is the one that's in the pub. So we remove the private. That one we know. Check that out. That one is sitting where it's close to the internet. Okay. So now you go to security aspect of things. We want to scroll this off a little bit. And we want to go to networking. We go to networking, VPC ID. Okay. There's something going on here which is different from what we had before. If you look carefully here, you have this. That is the public IP address. This is the inside IP address that it has inside. What this means is if you try to access this from here, using your PuTTY and you put this IP address, it's not going to work. But if you use this is why you might need a routing table. But we'll go ahead and test it. Since we have a public and private key and we have a private key to access it, something tells me you should be able to, if you have a gateway, you should be able to send it to where it's supposed to be. So let's try it. So for that, VC pop, we can use VPC, the DNS. The DNS. Let's see if we can open this address from here. I click on it, it's not doing anything. So another option that I have is, since in the security group I'm allowing all traffic, I will go ahead and try to test it out to see if I can get it. Copy. We use Ubuntu, so we're gonna go to PuTTY. And we have 3 minutes to wrap up the class, which is awesome. We did good. So we're gonna go here and open it up. Open it up. So we say Ubuntu at, and I pasted that IP address that I have in there, and I put VPC pub here, and I save it. It's okay, but I have to go down to SSH and go to auth and look for corresponding private key to access that, which in this case I might not have, but I'll find it somewhere. AWS. I'll check the desktop here. Check the AWS program. I didn't see anything there. I scroll down a little bit. I didn't see anything there either. I go to this one. I go to Cloud Movement. I didn't see anything there. So I'll use my USB and I put it here. Maybe I will find it in my USB drive. Okay. We go here. Go to this one. We go to this keys here. Nothing here for me. I have the key somewhere. Let's check again. No need to panic. It's somewhere here. Didn't find it here either. Let me rethink. Yeah. AWS servers. That one is not working for me. I'll try this one. There's nothing there either. Wow, I don't find anything, people. Okay. Okay. It's MOVE, right? This. Didn't find it. Let's try it. It might be the same one. I'm not gonna save it because I'm not sure, but let's try it. See if it's the same one. Apparently, it's not the same one. It's taking too long to do anything. Okay. So when you do it and you're not able to access it, there are too many things that could cause it. It could be the security group. You're not allowing. Okay, it says the time's out. So it could be a security group, instant launch. Go down. You check security group. You can check the security group as well. See which one default. So I believe I used this one. And in the inbound, let's see what's in the inbound. If even recognize it as SSH. All traffic. Well, it says all traffic. So you should be able to allow that to come in. Let's say I use the other one, which is this one. I'm not sure I used that one, but this one is all traffic, okay? It's supposed to go in. So with that being said, it could be other things happening here. Action. Let's say we added manage security group. So I don't think security group issues. It should be something else. I think it's the routing table issues. Also, I will take care of the routing table issues, guys. But basically, this is how you set up just a part of the VPC, the public part of it, and we'll do the private part of it next time. And by then, I'll probably took care of the the problem we're having now because you need to access it to see if you can get into it. Okay, guys. So with that, we're gonna wrap up the class. We did well today. It's 4:30 at this time. The 2 hours are up. The 2 hours they're up. And I thank you guys for showing up to our training section, IT Foundation, and AWS Cloud Training, codename iFACT. We always like to thank Lockdown for helping us and supporting us with the program. And we always love the fact that you guys put in the courage to show up and be a part of the program. Thank you guys a bunch. And I hope to see you guys again. And let's keep pushing and let's not tarry and let's not stop. Let's keep the fire burning. Thank you guys again. This is Josiah again, your lead instructor, saying goodbye.
Thank
Thanks,
you.
Sid.
Thank you.
Thank you.
All right. Hello. Mama. Mama.
Say, Daddy. Daddy. Say, I put my pee-pee in the potty twice. Say, yeah, I'm a big boy. I'm a big boy. And I'm big and strong. Big and strong. All right. Love you. Love you, Papa. Say, talk to you later, Daddy. Daddy.